Welcome back to another video. So this will be just me filming from the cell phone, and I have shown this before, and I have put this in another PCB which I will make another video about, but for now I'm waiting for that board. And you saw me in a previous video I did this, and that didn't work so well. I think the sensing which is out here and the temperature is here, like it's not great, and it pulls a lot of current. So I was thinking, maybe I can do some current measurement, and if I did some current measurement we can measure the resistance, and the resistance changes with the temperature. So I was thinking of using this PCB track as a thermometer itself, so, or a sensor. But as you can see, we have the MLX 90614. So basically it's an IR sensor which I'll put on I2C, and it's in parallel actually with the display there, as you can see, which is pretty cool. That's the deal with the I2C anyway. So I've been looking at the code, and yes, I have 80s neon colors here. Anyway, let me just pause for a moment. Okay, so I'm just gonna disconnect here, and I'm going to hook up power from the Arduino, which I used to program this UPDI thing with. So there you see, I've added another number there. You see 26 first. That's the new number. It's coming for this. It's actually higher precision than that. I think it's half. I'm not sure, but if I look at double values, you can see a lot more detail though. But look, if I put my hand under here, it's really fast. Take my hand away, 26. Put my hand in, 24, 34, 26. At the beginning of this video I said the measurement of temperature here is really flaky, or that was what I was indicating anyway. So there's no doubt in my mind why many of these projects have bulging PCBs. Right, so I'm over at the Discord, on a Discord called Solder Reflow Plates. It's a part of the Discord for these projects, and I saw a picture of a board that had bulged. So if I can find that, it will be great. Here's someone adding a thermistor on the back. I'm not sure how success he had, so that will be interesting to see. That's my previous video. Yeah, there you go. So this is the picture I was looking for. So you can see, yeah, basically I think he just overheated the hell out of it. So yeah. Anyway, what I was going to say about the current measurement is that a little bit based on the comments, I kind of lost interest again. I know I shouldn't listen to others, but it was kind of a buzzkill. And it's true, it's not a feasible project. It's more of a what if kind of project. And if these break, like often it's like, why don't you buy a proper one, like with a heating bed and everything. So yeah, but and this one is like $10, so it really adds to the cost of the whole thing. So, but can we see if we can get a lot of life out of this if we measure more correctly? The first thing I had to do was to add the library for the MLX 90614. So in Arduino IDE, it's much easier. You just select the library from the drop-down menus and everything. But in the Platform IO, I learned that you just add a line here, which is pretty easy, but you need to know the line. So that's a website. You can just search for the library you want, and then you get the line you want. So when you then press build down here, it will download and then build the library. So that's cool. So that works, and now I have the library up here. You can look at it if you want. We'll get back to that in a moment. So here's the main code, main C, and the first thing you need to do is basically just add this line. You can find a tutorial for that. It will include a header, just like you included the display header. So, and then you can see the display here is initialized, or it's not initialized, it's instantiated, and same goes for the sensor. So the next thing we need to do is to say begin. So there you go. So I'm using the default settings, that's why there's nothing inside here. So if we control click it, no, this is not right. Control click here, you can see the default value is address 5A there in heat animate. That's where you see it says heating like this, and it has large text for the heating. Anyway, here's the IR temperature. It's a double value. So alright, so let's power up this thing. We will have to heat this one and then the power is on. Alright, so the firmware I have uploaded is using the same code as before. The only difference is that I'm printing out the value. Alright, so the serial connection here, I made actually a connector for that, but it didn't work with my TTL to USB adapter. So I have drawn a schematic. I just pause the video every 5 seconds. So here you have 160 degrees. Here you have the target temperature curve, which goes up to 120. You have the LM85, which is this guy over here. And then you have the IR sensor, which you can see overshoots a lot, and like drops another 30 degrees, and then it goes out of the page, which is set to 165 on the scale here. So yeah, this is not great, but it was interesting to see how badly it performed actually. Right, I have programmed it. I only added one single line and that was in the get temp function. I'm just basically overwriting T, which is being calculated carefully above here, but I am basically just taking it directly from the sensor. So everything else that is using this get temperature is now going to be that value. So now I can actually, we saw that it was melting at 140 something, so let's set it to 150 and start it. If you ask me, that was a lot better than before. So we did see it got up to 146 and the solder started to melt like we have seen before, and the PID regulation was just kicking in like, yeah, so the power supply is now coming down and the temperature is coming down, so I think this is a success. Alright, so this is the old plot and the new one is a lot better. As you can see, it hits the target temperature of 150 C perfectly spot on. What it doesn't do is doing the end at the correct time, so it goes to the end at 210 and the end is supposed to be at 260 so according to the firmware, so something is wrong with the timing here in this chip. So but you can actually see the actual set temperature. So if I look at that, it's rather close to the IR temperature, this circle there that I noted for the target temperature. But yeah, so maybe that's why this heating can't keep up, because it's too quick anyway. So I have a feeling that the temperatures around the PCB is now hotter than the set point, so you have to watch out for that as well. should have melted now, but it doesn't. Oh, there it goes. That's good. Found another pitfall. I didn't realize that burning the fuses was a second step, because now I'm at 16 megahertz again and the flushing seems to be correct now. So what I had to do was in PIO, I had to go to this one, I think, set fuses, and when you click that it will set the fuses. And if you scroll up here you can see the settings, which is basically 16 megahertz. I think maybe this one, because I had programmed it at some time by the Arduino, it was at 20 megahertz. It could have been something there. This is so silly. So yeah, probably though. Oh, damn it. Yeah, so in my getTemp function here I return T, and I figured that I would do a isNAND ST, then it will turn off the green LED, so digital right LED something, green pin to low, delay for 50, okay, 100 millisecond, digital right LED green, right. Yeah, so for 100 millisecond it will turn off the LED. Not sure if low is on or high is on. I can check that quickly actually. High is on, so that's good. Let's get this away. Alright, so I think that's it. We'll turn it back on again. I'll just flush it off for 100 millisecond and do another reading. If it's still none, then it will do the same. Okay, I need to attach the programmer as well. Alright, so it's been a week since I did the last video or something like that. So what I did was run into a lot of problems. I have a lot of footage, but then the video will be like an hour long, so I will just explain what happened. So I had a bit of trouble with the IR sensors. Say it returned non-numbers, which means not the number. What I end up doing is rewriting that getTemp routine and flash the LED every time it retries, and I implemented retry. So, but sometimes on some few occasions it would retry so many times that it got stuck in the retry routine. So then the board would heat up and it could be damaged. I had to stop the process. But it seemed to help, and I can still use it. So, and I bought it off AliExpress. It could be that it's not genuine, or just put it bluntly, it's fake. But yeah, so another problem I have is that 80 mega 4809, I can't get serial. The serial connection is back here. It's actually not a connector, it's just SMD pads. So what we can do then is try some other ports, maybe, because this chip has several serial ports. So Yeah, so I've been discussing a little bit on the Discord for their Spats board, which is this one is made by or hosted by on GitHub. And someone said that this sensor was not viable because it had a big delta value. You know what? When you look at this temperature profile here, I think having the sensor out on the side is really not viable. Maybe a thermocouple could do it. Because there's something about this, you see this long reaction time, it's really crazy. It's like, it's almost a third, the reaction time is almost a third of the whole profile, or something like that. Maybe it follows quite nicely in the beginning, but no, I don't really like it. So, and another thing that was much more concerning is that when I measured the IR temperature from regulating the LM85, meaning using the original firmware, but just looking at what temperature the IR sensors see, it's like 30 degrees drop here. So that's why I had so much. Remember, you see some of the previous videos, it started soldering and it stopped, and then it started soldering again. So it sucks so bad. Anyway, maybe the original designer managed to tweak it a bit, so I don't know. But I noticed something else in my code, and it did follow a lot nicer, but the kind of ending is a bit early here at 210, but it's supposed to end at 260. So figure out when you're using platform IO, it doesn't automatically write the fuse bits like Arduino does. So when I wrote the fuse bits, it was set to the correct frequency, and then we got the correct profile. So I think the microcontroller was running at 20 MHz, but the software said 16 or something like that. So I don't take my word for it. So you can see the orange line. That's the one after writing a fuse bits, and you can see this is my first attempt. Stops up here, and you can also see the set point was a bit fast. That's those small circles up over here. And those are the actual set point that follows the profile, but it didn't. So when I adjusted the when I wrote the fuse bits, you can see the set points follow this curve pretty nicely. So you can also see the orange one, which is the IR temperature, is following quite nicely as well. It's a bit up and down here, but when it slows down a bit, the profile, it follows really nicely, but then it sort of can't follow. It's like, here it kind of looks like this is like 1 centimeter here, it's like 10 degrees or 10 seconds. So 1 square is 5 seconds, so you can see it's almost over 10 seconds slow, like 12 seconds slow or something. So I only get a little nudge over the top, but that shouldn't actually matter if the soldering temperature is down here somewhere. So you just get over the top. So maybe I should just go to, this is 150 anyway. I was soldering at 160. So maybe if I go to 170, everything will be fine. So I really like this approach. I will use it more. I think this is really an interesting solution. Maybe not the cheapest one. So another solution could be almost forgot to say that. When you put a board on here, this is not a board anyway, just a big board. Let's say you're soldering this one. Oh, you don't see that. Oh, it's a bad example. There's something in here. You have this board, and then you put this one under the IR sensor, and then you point at it. So you could do that. I have to tighten up this connection anyway. But yeah, if you did that, yeah, it will measure the surface temperature, and that's even better actually than measuring around, because this will have a delta temperature other than the board. So that's pretty cool also. Okay, I think that will be it for this video. There are some things I would like to try, like automatic P tuning. So someone else, I will show it on the screen. I had did a firmware for that. I found that interesting, but it's not very good at the moment, he says. So
So you probably need some time. There's something called nickel something, I don't know. Yeah, so hope you liked the video. Thank you very much for watching, and see you another time. Bye bye.